Hello, and welcome to a calculus tutorial by Physics Man Education. I'm Physics Man, and you may recall that in a previous tutorial we started talking about the x and y intercepts of a quadratic function. Now you may also remember we discussed that because quadratic functions are parabolic in shape, that you may in general have up to and including two unique x-intercepts or roots. And I promised you that in future videos we'd start discussing some strategies about how to find these roots, and you can always trust Physics Man when he makes a promise. This is going to be the first of those tutorial videos. We're going to be discussing the general format of how to find the roots of a quadratic function by factoring the quadratic function. So, and then because this will be quite abstract, and our very next tutorial is when we're going to give you a concrete example of exactly how it works. So we're going to start by writing the general form of the quadratic function that you've seen 10.5 million times by now. And we're going to remember that in order to find a root of this function, we require the point to be along the x-axis, which means that y has to equal 0. So the equation that we're going to solve is 0 is equal to ax squared plus bx plus c. In order to do this, we need a couple of dummy variables. And we're going to call those dummy variables I and j. I and j will be defined by the following two conditions. First of all, I times j has to equal to a times c. The second necessary condition is that I plus j equals b. Now, when you're given the quadratic function, you will know a, c, and b, but you won't know I and j. This is two equations with two unknowns, which in general you can solve. It's a bit of algebra that we've learned. It's actually linear algebra that we learned in previous tutorials. But this allows us to write the following expression here. Instead of saying ax squared plus bx plus c, we're going to write, very similarly, ax squared plus ix plus jx plus c. Where we made use of the fact that I plus j equals b, therefore ix plus jx equals bx. So we haven't really changed our equation very much yet. However, this does allow us to do something really cool with this particular line. From the first two terms, we can factor out an ax. So we have ax times x plus I over a plus, and then here I'm going to factor out just the j. So I'm going to have j times x plus c over j. Now so far, it seems like I'm just making this unnecessarily complicated, and why would I ever want to do something so stupid? Here's the cool part. I can rearrange this. And if I rearrange this, I find if I bring a to the other side and j to the other side, I find that I over a is equal to c over j, which means that these are both the same number, which I'm going to call d. Which means that this can now be simplified slightly. Ax times x plus d plus j x plus d. The dog's making a noise. Anyways, now that I have the same term, or the same factor in both these terms, I can factor out that factor. So I'm going to get ax plus j times x plus d. And, of course, this whole thing is still going to equal 0. Now, there are two conditions by which this can go to 0. In order for this to go to 0, we require either this term to be 0 or this term to be 0. Because if this term is 0, then whatever this term is, the whole thing will be 0, and vice versa if this term is 0. So we can actually write the next two equations, or two solutions. Ax plus j equals 0 will give us one solution, and all we do here is solve for x, so ax is equal to negative j, x is equal to negative j over a. And that's going to be one of our roots. And that is a full solution since j and a are both known. As mentioned earlier, our other solution comes from this term equaling 0, so our next solution will be x plus d equals 0, x equals minus d, minus d will be equal to minus c over j, both of which are numbers that we will know, so that is our next complete solution. And that gives us, in general, two roots. And notice here that this only works if this equation can be factored. In other words, if both these variables can be found such that this system of equations is always true. That may not always be the case. In our next tutorial, I will show you an example of when it is the case and we can use factoring to solve for the roots of a quadratic function. And in tutorials after that, I'll give you some more generally applicable ways to solve for the roots of the equation. Thank you very much for watching. This has been a production by Physics Man Education, and I'm Physics Man, and as always, I'll see you in the future.